Today, we've got some exciting news. Tencent just released a new AI model that's faster, smarter, and has a crazy long memory, including both fast and slow thinking modes. Then, baidu took things to the next level by building a search engine that can actually reason, using 4 different AI agents working together. And just when we thought things couldn't get any hotter, BYU and Huawei both open-sourced their biggest models yet, with hundreds of billions of parameters, basically starting an open-source showdown with OpenAI and the rest. Let's dive in. Let's start with Tencent. They've just dropped a bombshell with the Hunan A13B, and the specs are insane. It's like combining a Formula One car with a hybrid SUV. The model is housed in an 80 billion parameter framework, but only 13 billion parameters actually fire up at runtime. That's the sparse mixture of experts trick. This means you get the power of a heavyweight model without the heavyweight energy bill. Inside, there are 32 transformer layers, swag glue activations, a huge 128,000 vocabulary, and group query attention, so it processes long prompts without ballooning the memory. And the context window? It's an extraordinary 256,000 tokens. This means the model can remember more than most people process in a lifetime. The training process was monumental, with Tencent feeding the model 20 trillion tokens, far more than most AI models have ever seen. After that, they fine-tuned it using a method called fast annealing, gradually increasing its memory from 32,000 tokens to an insane 256,000 token range. To handle this scale, they used something called NTK positional encoding, which ensures the model can track information in extremely long inputs without getting confused. But here's the twist. Tencent added a clever switch to control how the model thinks. If you add /noink to your prompt, the model speeds through the answer. If you add think, it slows down to reason step by step, perfect for tasks that require more thought. After the core training, they applied supervised fine-tuning and reinforcement learning to sharpen the model's skills. What's really impressive is what they did with tools. Tencent trained the model using over 20,000 different tool use scenarios, ranging from editing spreadsheets and writing code to running searches and checking rules mid-conversation. It even learns from its mistakes. Incorrect answers get penalized, especially if it messes up something technical like an SQL query. The results speak for themselves. It performs at the top of the class in tough benchmarks like math, CA Math, and GPQA. It scored 89.1 on BBH for logical reasoning, 84.7 on zebra logic, and did great in coding too, with scores like 83.9 on MBPP and 69.3 on multi-PLE. When it comes to agent tasks, where models must reason with tools, it leads the pack, hitting 78.3 on BFCL version 3 and 61.2 on complex Func Bench. And when it comes to long context stress tests like Penguin Scrolls and Ruler, it holds up impressively well, even at 64,000 and 128,000 tokens. Some larger models start to falter here, but this one excels. But Tencent didn't just stop at building the model, they made it deployable too. It works seamlessly with popular AI serving platforms like VLLM, SGLANG, and TensorRT-LM. It can run in different formats, including W16A16 for balance, W88 for lightweight devices, and even FP8K cache to keep things fast and efficient without consuming too much GPU memory. In real-world terms, this means you can run 32 conversations at once, each starting with over 240 tokens and continuing with up to 14,336 more, all while pushing nearly 2,000 tokens per second. This is fast enough for real-time summarization or live applications, and yes, it's completely open source. You can grab it on Hugging Face or GitHub with a license that lets you use it for everything from school projects to startup tools, without worrying about legal issues. Now, while Tencent was showing off the raw horsepower of their model, BYU's research team was focusing on a different challenge, creating search that actually reasons. Traditional retrieval augmented generation pipelines might look good, but they struggle when a query requires chain deductions or deals with conflicting sources. Most systems just grab a few documents, mash them together, and call it a day. For example, if you ask who outlived whom between Julius Caesar and Emperor Wu of Han, you'd get 2 birth dates, but no real answer. BYU's new search paradigm solves this. It uses a 4-agent relay system. A master agent watches the incoming query, detects its complexity, and then passes it to a planner if the query requires multi-step logic. The planner breaks the request down into a directed acyclic graph of subtasks, chooses tools from an internal marketplace, called MCP servers, and then passes everything on to an executive. The executive fires the calls, retries if necessary, patches any gaps in the retrieved data, and streams partial answers back. Finally, a writer agent filters contradictions, stitches sentences together, and produces a coherent response. In practice, when asked about the lifespans of Julius Caesar and Emperor Wu of Han, the system fetches both birth dates, calculates their ages, compares the numbers, and provides the answer. Wu of Han lived 69 years, while Caesar lived 56, so there's a 13-year difference. No manual calculations, no hallucinated dates. Depending on the query difficulty, the system scales by using just the writer, adding the executive, or bringing in the full planner layer. The result is a search process that plans, replans, and keeps working, even when retrieval tools fail. Now, let's talk about the big news on June 30th. BYU, the same company that once swore its Ernie line would stay proprietary, went full open source. They released 10 Ernie 4.5 variants on Hugging Face, with models ranging from a 300 million parameter version to a 424 billion parameter multimodal beast. Last year, Robin Lee declared that Ernie would outpace open models because it was closed. This year, he's making the weights, SDKs, and inference tricks available for everyone. The pricing angle is significant. Analysts already predict that open weights could slash deployment costs by 60 to 80%. BYU is even boasting that its latest Ernie X1 model matches DeepSeek R1's performance at half the price. For enterprise CTOs who are counting GPU hours, this is a major selling point. This move is putting pressure on OpenAI. Sam Altman has hinted that OpenAI needs a more open-source strategy, but GPT-4 is still locked behind the API toll booth. Now, BYU's open-source move, combined with Tencent's and DeepSeek's earlier releases, is cranking up the heat. The shift is palpable. Every time a heavyweight lab open-sources a top-tier model, it raises the bar for everyone else. Some argue that open-source models adapt faster, localize better, and foster new research opportunities simply because anyone can contribute. Meanwhile, closed models face the challenge of justifying their premium prices in a world full of quality open-source alternatives. The Chinese open-source wave is here, with companies like BYU, Huawei, Tencent, and others releasing massive models. The cost of running AI models has dropped dramatically. Chinese vendors have successfully created efficiencies that make large models now available for a fraction of last year's price. So, what does this mean for the future? As more companies move towards open-source AI, the licensing landscape is set to change drastically. By the end of next year, an estimated 85% of enterprises will incorporate open models into production. The days of expensive proprietary AI may be numbered. What do you think? How long can closed models keep charging premium prices when the open-source world is moving this fast? Let me know your thoughts in the comments. Don't forget to subscribe for more updates, and if you found this video helpful, give it a like. Thanks for watching.